Welcome to homework.
Okay, so we have a pretty interesting reaction here, which we're told a bit about. We're told that we start with this alkene, it reacts with HBr, and eventually forms, rather than a 5-membered ring, a 6-membered ring. And we're told that this is because at some point we form a carbocation, and that a rearrangement in which a carbon-carbon bond that was previously participating in the ring moves, right? Which is how we get our 6-membered ring out. And what they want to see is what the intermediates are that will lead to this. Okay, so recall that the first thing that happens is going to be that this double bond will swing open and grab the proton, like so, leaving behind the bromine. And this is where we generate our carbocation. So now we're going to go down here. And we're going to generate the most stable carbocation we can, which is the secondary one, whereas our hydrogen will attach here. And this is structure F. This is the carbocation that forms directly following addition of the proton across the double bond. And then we get our rearrangement, and which is to say that this bond right here will rearrange to be bound to this carbon instead. Okay. And that will produce the following intermediate. And in fact, by looking at this intermediate, structure A, I apologize. This is what you would put as your answer. I don't know what these would be labeled. Apologies. This is the intermediate that should, in fact, reveal why it is that this carbon-carbon bond migrates anyway, right? Because this is far more stable, tertiary carbocation rather than being secondary. In fact, the ring expansion also stabilizes the molecule. Okay, and then finally, this is where the bromine adds. That's not really important to the problem. So what we need to do is find from our list what the structure name is that corresponds to this, and that is structure C. So you want structure C in the first, and then it looks like structure F is what you want for your second one. So the first answer is C, and then the next answer is F.